Example is on how to use the previous material in solving problems, and we have here a circuit that is have combinations of series and parallel, and we're gonna assume here that we don't have any internal resistance for the power supply, and we will say here that for this circuit both meters are idealized. Idealized means that the voltmeter is going to have a very high voltage, a very high resistance, and for the ammeter, it is going to be having a very low, like almost zero. And the ammeter reads 1.25. What does the voltmeter read? Okay, and what is the EMF of the battery? The EMF of the battery is going to be, of course, the voltage that is provided here. In order to solve this, I need first to calculate what is really the values for our equivalent. Okay, and therefore, what I will do is I'm gonna look at the resistors, and I will say, usually I will say this is one, let's say two, three, it's easier to do that, four, and then this is five. And then here I can say 1 over 1, 2, 3, because these are in parallel, is going to be 1 over R1 plus 1 over R2 plus 1 over R3. And that is going to be 1 over 25 ohms plus 1 over 15 ohms plus 1 over 25 ohms. All right. And when I move with the math here, I should calculate, of course, for R equivalent for these three. Then I'm gonna use my calculator to calculate these numbers. 0.04 ohm negative 1 plus 0.067 ohm negative 1 plus 0.04 ohm negative 1. And then from that, I will be able to calculate that R, which is going to be R231. Like I can add the three numbers. Okay, the 0.04 plus the 0.067 plus the 0.04, and then take 1 over this value, and that is going to be my equivalent resistor, which is 6.80 ohms. Then I have calculated that, and then my resistor, it is like I know what is really that resistor is. Now I can now do the following. I have the current through the 25 ohms. Therefore, I can calculate the voltage for that resistor, which is gonna be, I call that R1 times I1. And that is going to be the 25 ohms times the 1.25, and that is going to be 31.25 volts. Now, if I know what is going to be the voltage across R1, this is going to be the voltage across R1, the voltage across R2, the voltage across R3. Now, if I wish to calculate the current through the 15. Here I'm showing you like so many things we can do. If I want to see the current across, the current through, the current through the 15 ohms is going to be I 2, which is the same voltage, which is, I'm gonna call it V divided by R2, and that is 31.25 volts divided by 15, and that is gonna be 2.08 amperes. You should be able to, always work on, circuits and analyze this like this. Find any voltage, any current. Okay. Now also, I will say now, since this resistor, the last one 15, okay, which is R3, then it should have the same current. Here I have 15, 15, and 25. Then I can say that I total is gonna be the first current, which is the 1.25 plus the 2.08 plus another 0.08, and that is going to be, like, if I add all these, that is going to be 5.41. And from that one, I can calculate the voltmeter reading, which is across the 45. Here I will say, of course, it's going to be the same current going through it, because like the equivalent of these three is going to be having that current going through. Then 45 has the same current, and from that I can say that the voltmeter reading is going to be I total times R, which is I called 4. Then this is going to be 5.41 amperes times 45, and that is gonna give me the 243 volts. Now also I can calculate the voltage across number 5, because I know the total current. Then it's gonna be I, the total, times R, which is I called R5. And that is going to be the total current, 5.41 times 35, and that should be 189 volts. And then for the EMF, I will say the EMF is gonna be all the voltages, V1 to 3 plus V4 plus V5. And I will, I know that I can calculate, like I calculated here, the voltage as 31.5 here, 31.5, 35 volts. And for number 5, it was 189. And for the number 4, it was the 243. Therefore, I should have the voltage here as 243 plus 189 plus 31.5. And that is gonna add to 464 volts. Okay, then this is an application. If I wish to calculate what is really the equivalent resistance also of the whole circuit, like I can verify the current by having, now I have calculated my total resistor to be 6.8 for 1, 2, and 3. And then I have here, let me do this. Then I have this, this is now my new circuit. This is 45. And that is 6 point, what I have it here, 80. And I have this one as 35. My total resistor for the circuit is going to be 45 plus 35 plus 6.8, and that is going to be 86.8 ohms. If I wish to calculate, like just to check, I total, it should be the voltage that I have here, which is 464 divided by 86.8, and that is gonna be 5.35 amperes. Is it? Almost, yeah, because of course the approximations, but just here I did the, you know, the calculation based on the values that I got. Okay, then this is an application for on how to use the, you know, the analysis for, like, these are considered to be simple circuits, but they have a combination of series and parallel connection. Thank you, and see you soon in another you know, video.